Hey, welcome. In the world of manufacturing, whether you're making parts for a jet engine or a surgical implant, speed is absolutely everything. But what really truly drives that speed? Well, today we're going to dig into the one number that rules them all, the material removal rate.
Just think about it for a sec. If you had to boil down the entire efficiency of a factory into just one metric, what would it be? It's not about how fast a spindle can turn. No, it's about how fast you can take a raw chunk of metal and turn it into a final precise part. And that, my friends, is all about the material removal rate, or MRR for short.
So here's our game plan. First, we'll talk about why MRR is such a big deal. Then we'll get into the three main levers operators use to control it. After that, and this is the juicy part, we'll explore the trade-offs. Why just going faster is a terrible idea. Then we'll look at the support systems that let us go fast. And finally, we'll put it all together to find that perfect, optimal balance.
Okay, let's start at the very beginning. In any modern machine shop, the name of the game is productivity. You want to make high-quality parts, you want to make them fast, and you want to do it without breaking the bank. And that's exactly where MRR steps into the spotlight.
So what is it? Put simply, MRR is the amount of material you're literally carving away from a part every single minute. The higher your MRR, the faster you're getting the job done, and the more productive your whole operation is. It's basically the horsepower of your machining process. So, how do you actually turn up the dial?
I want you to picture a machinist's control panel. Now, there are tons of variables, but there are really three main levers they can pull to crank up that MRR. These are the big three, the fundamentals that directly set the pace for production. Let's break them down.
First up, you've got cutting speed. Think of this as how fast the edge of the tool is moving across the material. Then there's the feed rate. That's how aggressively the tool is plunging forward into the workpiece. And last, you have depth of cut. That's how big of a bite the tool takes on each pass. Now, you crank any of these up, and your MRR climbs. Sounds simple, right? Well, not so fast.
And this right here is where things get really interesting. See, just pushing any one of those levers to the absolute max comes with a serious price. It is the classic case of more speed, more problems. Each one has a critical trade-off that can wreck your quality, your budget, and even your machine.
Let's start with cutting speed. So you can see here, you jack up the cutting speed and, yep, your MRR goes through the roof. Looks great. But look what happens to your tool life. It just tanks. Why? Because more speed means more friction, and more friction means way more heat. Studies on super tough materials like titanium alloys and high-strength steel show this again and again. You might be removing material faster, but you're also basically melting your expensive cutting tools.
Okay, lever number 2, feed rate. You push the tool into the material faster, and again, your MRR goes up. But the trade-off here, your surface quality can get really bad. A higher feed rate often leaves a rougher finish, which is a total deal breaker for things like lightweight composites or aluminum alloys, where that perfect finish is critical.
And finally, we have depth of cut. Now, taking a huge bite of material is the fastest way to boost MRR, for sure. But it also puts an enormous amount of mechanical stress on both the tool and the machine. Tool stability goes way down as those cutting forces skyrocket. There's research on hard tool steels, the kind used to make molds, that shows if you go too deep, you don't just wear out the tool, you risk a sudden, catastrophic failure.
So if jamming the levers to the max just causes problems, how in the world do people achieve these crazy high MRRs without everything just blowing up? Well, the answer is in the support system. It's all the other stuff, the enablers, that lets you manage those trade-offs and safely push the limits. Your first thought might be, well, just get a stronger tool. But honestly, that's just scratching the surface. The real solution is way more sophisticated, and it starts with the design of the tool itself. This is where we talk about upgrading the whole system. You can tweak the tool's geometry, like its cutting angle, to slice more efficiently. You can use incredible materials and coatings like alumina, which is a super hard ceramic, to make the tool way more resistant to heat and wear. You can even freeze them with cryogenic treatments to make them tougher. And then there's the software, which can create these brilliant tool paths that keep the load on the tool constant, letting you run faster without dangerous spikes and stress.
And now check this out. This quote really hammers home the impact of another key support system, cooling. I mean, look at that number. Just by using a smarter way to lubricate the cut, researchers dropped the temperature by over 17%. That directly fights the #1 enemy of high cutting speeds, heat. It lets you have your cake and eat it too. Higher MRR without burning up your tools.
And that's just one technique. This chat table shows a few of the advanced methods out there. You have things like minimum quantity lubrication, or MQL, which uses a tiny bit of oil to cut friction. Traditional flood coolant is good for preventing certain types of wear. You can even use liquid nitrogen to stop wear at an atomic level. Or use high-pressure coolant to actually reduce tool vibration. Each one is a specialized weapon to fight the hidden costs of high MRR.
Okay, so let's put all the pieces together. We've got the levers that give us speed, we've got the trade-offs that create problems, and we've got the support systems that help us solve them. This all brings us to the main event. Real mastery isn't about brute force speed. It's about smart, sophisticated optimization.
So here's the absolute key takeaway. Just redlining your speed, your feed, or your depth of cut is a rookie move. True, long-term productivity comes from finding that perfect sweet spot, that elegant balance of all these different factors working together in harmony.
Let's just put these two mindsets side by side. The maximum speed approach focuses on one number, and it almost always ends in broken tools, bad parts, and expensive downtime. But the optimal performance mindset? That's about total efficiency. It's about balancing everything, the levers, the tooling, the cooling, to find the highest sustainable rate of quality production. And that right there is the secret to world-class manufacturing.
And all of this leaves us with one final question. It's a question that every single machinist and engineer has to answer for every job they run. Are you just chasing the fastest cut, or are you engineering the smartest one? The answer to that question is what separates the good from the truly great. Thanks for tuning in.